Welcome to the fastest way to learn data structures and algorithms with this premium revision material. Today we are mastering LeetCode 12, the integer to Roman challenge. This is a classic string manipulation problem frequently asked in interviews at top tech firms like Amazon, Adobe, and Apple. Let us look at the problem statement. 7 symbols represent Roman numerals, from I, which is 1, to m, which is 1000. Usually, we write them largest to smallest, but 6 special cases use subtraction. For example, 4 is written as IV, and 9 is written as IX. Our task is to convert any integer up to 3999 into its Roman numeral representation. Think of the challenge here. We cannot just convert each digit in isolation because symbols like CM or XL combine values. The easiest way to think about this is like making change at a cash register. If you owe someone 86 cents, you start with the largest coin, a $50, then a quarter, then a dime, and so on. Imagine you are a medieval accountant. You have a stack of pre-cut stone symbols sorted by weight. You have 1,000 pound M symbols, 900 pound CM symbols, and so on. To represent a specific weight, you always grab the heaviest stone that does not exceed your remaining total. This is our golden rule. The greedy subtraction strategy. By treating subtraction pairs like CM as single symbols, we can solve this in a single pass. Now, let us dive into the dry run. This is the most important part. Look at the screen. We have our target number, 3749, at the top. On the left, we have our reference map of Roman symbols sorted from largest to smallest. Notice the caption box at the bottom tracking our steps. First, we look at m, which is 1000. It fits into our total 3 times. We add MMM to our result and subtract 3000. Our remaining total is now 749. Next, we check 900, too big. We move to D, which is 500. It fits once. We add D to our string and subtract 500. Now we have 249 left. Moving down, we see C, which is 100. It fits twice. We add CC and subtract 200. We are left with 49. Look at the highlight, we reach L, which is 50, too big. But next is XL, which is 40. It fits. We add XL and subtract 40. Only 9 is left. Finally, we check 10, too big. But IX, which is 9, is a perfect match. We add IX, subtract 9, and we are done. The final result is MMMDCCXLIX, perfect. Now that we have walked through the logic visually, let us see how this translates into our Python code. We define a function called int to Roman. We start by creating a list of tuples called sim, containing our values and their corresponding Roman symbols, sorted in descending order. We initialize an empty list called residential to store our characters. Then, we iterate through each value and symbol in our reference list. Inside the loop, while the remaining number is greater than or equal to the current value, we append the symbol to our result and subtract the value from our total. Using a list and then joining it is more efficient than string concatenation in Python. Finally, we return the join string. Looking at the complexity, the time complexity is O of 1. Although there is a loop, the number of Roman symbols is fixed, and the maximum value is capped at 3999. The space complexity is also O of 1, as the size of our symbol map and the result string are constant for the given constraints. And that is the integer to Roman challenge mastered. Save this video for your next interview revision, and follow for more deep dive DSA explainers. Send this to your coding partner.